Hello everyone, hope everyone's doing well today. Give me a second to get set up here, make sure we're live, change the stream title, all that stuff. All right. There we go. Okay. I am all set up. Thank you for your patience. If anyone's here, go ahead and say hi in the chat. Let me know you're watching, listening. But other than that, we're just going to go ahead and get started. So, what are we doing today? Well, we are going to be talking about regular expressions in R. I'm going to be using the stringr or stringr package, however you want to pronounce it. The stringr package is great for working with regular expressions. It's not the only way to do regular expressions in R, but it is one of the more convenient methods. But the point of today is not really to talk about the stringr package in particular, but rather to just sort of focus on regular expressions and what they're good for. So with that, let's go ahead and get into it. Okay, so first I just want to sort of motivate why regular expressions are cool and interesting. And so to do that, what I'm going to do is just sort of copy paste a really kind of scary looking regular expression here. My goal for today, my hope for today is that if you watch this video the whole way through, you will understand what this is doing by the end of the video today. So if this looks scary and confusing, great, you're in the right place. The goal is to figure out what's going on here, and by doing that, you'll be able to use regular expressions hopefully in your own work. So what is this actually doing? Well, instead of talking about it, how about I just show you? If you do any work with strings, you'll probably find yourself in a situation like this where you have some messy data, right? Here I've sort of created a situation where maybe a user was entering their phone number, and you can see there's sort of all of these different formats and sort of all of these different responses. And if I want to do an analysis on the phone numbers, for example, if I wanted to know all of the area codes, it's not clear how to actually sort of pull that information out of my vector here. So this is what regular expressions are for. That's what this sort of complicated pattern is going to do for me. It's going to pull the phone information out from this sort of complicated and messy character vector that we have here. So go ahead and run this to define the phone numbers variable. And next I'm just going to show the function that we're going to be using today for the most part, and that is strmatch. Strmatch, like I said, comes from the stringr package. There's a bunch of other functions we're going to be talking about I think just one other one today. But the stringr package, like I said, does a ton more beyond just matching. But we're just going to be sort of working with regular expressions today and not exploring the additional functionality in the stringr package. So what does str match take? The first thing that it's going to take are the strings that we actually want to do something with. And then it's going to take our pattern. So this is all you need to go ahead and use this function str match. You need a string or a group of strings, and then a pattern. Now, actually coming up with this pattern is the tricky part. So that is what we're going to be talking about today. But you'll see once I run this function here, what I get out is a matrix. And you can see all of sort of the messy formatting has been dealt with, right? So I'm getting out an area code, and then sort of the second grouping of 3 numbers, and then the final 4 numbers of the phone number, right? And so this is going to be a lot easier for me to work with in my analysis than dealing with all of these different strings. Okay, and I often see situations in people's code where they're dealing with kind of messy strings, and they try to use some combination of modification of the string, making it a lowercase, and then trying to take out all the values that are not numeric or something like that, where you're just sort of like applying maybe 3 or 5 or 10 different functions to try to sort of clean this up yourself. Regular expressions allow you to sort of pull out the information you actually care about with one function, right? All you have to do is know how to define this pattern. So if that sounds interesting to you, great. It's super helpful. One of the things that I think more people should practice and learn about. So hopefully you can sort of think of a situation where this sort of power would be useful to you. One place that I use it all the time is with file names and parsing file names and getting sort of particular information out of file names. For example, if I'm using another researcher's data and there's some important information in the file names that I want to pull out. Often it's easiest to just do something like that with a regular expression. So, okay, cool. That's sort of the motivation for today. I do want to point out this website, which is the website that I use to learn regular expressions. I want to get in sort of pretty deep into regular expressions today, but if you really want practice with them, if you want to do some exercises yourself, I definitely recommend going to this website, regex1, and just doing the sort of interactive exercises that they have, because they're super helpful, and you'll sort of get the entire experience of regular expressions versus what we're going to do today, which is just going to be a subset of everything that's out there. So, okay, let's get into our very first pattern. We're going to start simple, and so to do that, we are just going to define some very simple strings, ABC, ABCD, ABCDEF, and XYZ. Okay, so these are the letters that we want to do some sort of operation with, right? So we'll go ahead and use this str match function, pass in our letters, and now what do we want our pattern to be, right? Well, that depends. What do we want to match? What information do we want from these strings? For now, let's just say we want to get out all of the ABC matches, and maybe we want to use this to figure out which of these strings contain ABC. Okay, easy enough. Our pattern then is just the letters ABC. Okay, so this is the sort of bare bones, simplest type of pattern. Nothing special is going on. You're just putting in the letters that you want to match. Okay, so let's run this and see what happens. our match that we get back from our str match call is going to be ABC and ABC and ABC, right? So here it matches ABC, and here it also matches ABC, and here as well, right? So the part that matches is what's returned to us, and then here XYZ does not match, so we just get NA back for that value, right? And so maybe this is, useful. There's other ways of sort of like checking if you have a match, if that's your actual use case. But this is just sort of an example of the absolute simplest pattern that you might have. And so you might ask, like, does this work for just letters? Can you do it with numbers as well? And the answer is yes. So let's say we had some sort of text field where people were asked to enter their favorite numbers, right? And so we want to see sort of everyone who has a 42 in their text field, in their entry. And so we can do the same thing with numbers, right? So now when I run this, hopefully you can sort of already imagine what our output is going to look like. So just think about that for a moment, and I'll go ahead and run it. We get back 42, right? It matches the 42 here. If there are other characters that don't match, that's fine. What str match is doing is it's just finding if there's a match, and if there is, it returns what the match is. So same thing here. We match 42. 24 does not match. Okay, so this is ordered. 24 doesn't match, and so we get NA back. Okay, so hopefully that makes sense. This is like the most basic thing they can do with regular expressions. It's not super useful. It's sometimes useful, right, if you want to check if a very specific string of characters is in your string, but oftentimes programming languages will include that sort of functionality in other ways, so you don't have to actually use regular expressions. Where regular expressions really shine is when you have some sort of pattern, right? So going back to our phone numbers, we had what looks like all these sort of special symbols here. Those special symbols that sort of represent more abstract concepts, those are the things that actually make regular expressions really powerful. So let's go ahead and show off some of those sort of useful, powerful, what are called special characters. So I'm going to define another vector here called favorites. And here, this is again like you had people type in what's your favorite number, and maybe they typed in things like my favorite is 42. I like 10. And someone said 33. Maybe this is like a transcript of a conversation, right? Something like that. In this case, right, we can't match just 42. What we want to know is what their favorite number is, right? And so we're interested in sort of any numbers that are in our text. It's not just one specific number. We just want to sort of pull out all of the numbers from each of these strings. So to do that, we are going to, try to type this in here. We are going to use the special character \d. So in regular expressions, \d represents a number. Now I'm going to go ahead and run this, and we are going to get an error. If you are working with regular expressions in R, this is the sort of error they might recognize, so I wanted to point it out. In Python, there's something called raw strings that you might use for regular expressions or for file paths. In R 4.0, there are now raw strings. But if you're not on 4.0, you can't use that feature. Instead, what you have to do is escape special characters in strings. And so what does this error actually mean? \d is an unrecognized escape in character string, blah, blah, blah. The simplest way of interpreting this is to just remember that you need to escape special characters in your string like backslashes. And so we are going to use a backslash to escape our other backslash. It's kind of confusing. If you learn more about like string formatting and sort of the whole world of working with strings, then you start to sort of learn some of this stuff. If that's all new to you, that's fine. If you're working with regular expressions and you get something like this, look to see if you have only one backslash, just add a second one and you'll escape that backslash, right? That's what it's talking about here with this escape. So anyway, I just wanted to show that briefly before moving on. Let's remember what we were actually talking about here, which is that we want to use this special character to get numeric information out from our strings, but we don't want to necessarily define a single piece of numeric information. We just kind of want to get all the numbers out. So that's what this pattern is going to do for us. It's going to pull out numbers. Now I'm going to run this, and the results might not be exactly what you expect, right? We get a 4 out, a 1 out, and a 3 out. Why is that? Well, what this is doing is it's pulling out the first match of this pattern in our string. So once it finds a D for digit, like the 4, it's going to stop and return that 4. And that's it, right? And so here it's returning the 1 in 10 and the 3 in 33. Okay, obviously that's not what we want. We want sort of the full 42 and 10 and 33. And we don't want to have to put a limit on the number of digits that are there necessarily, right? Someone's favorite number might be 110 and someone else's favorite number might be 7, and we sort of want to account for both of those sort of circumstances. So to handle this, what we're going to do is introduce our next special character. Our next special character is the plus symbol. So before I explain what this does, I'm just going to go ahead and run this so that you can see. Go ahead and run this so that we can see. Now we are getting back our full numbers that we want, right? We get 42 and 10 and 33. And just to show you, right, that this would work with numbers of different lengths, I'll go ahead and rerun this to overwrite our favorites variable and run this, and you can see, okay, we do get our full numbers even with numbers with different numbers of digits. So, okay, let's go ahead and go back to the numbers that we had before, 42, 10, and 33. Okay, so we just added this plus here, and now all of a sudden we're getting the behavior that we want. What is this plus actually doing? The plus symbol says, give me one or more of whatever is before the plus symbol. Okay, so this means digit. Really, this whole thing means digit. This says, give me one or more. Now, regular expressions are what are called greedy algorithms. So when our algorithm is sort of parsing the strings and trying to match our pattern, if it can give us more digits, it's going to give us more. It's going to try to soak up as much as it can. And so here it soaks up both digits because we said match one or more. Okay, up here, this is just a single digit. It finds the first digit in our string and then returns that. So adding the plus makes it greedy and gets our gets the parser to just soak up all of the digits that appear in a row. Okay, so we've already learned two special characters. Okay, we have learned the digit specifier and this plus symbol, which is one or more characters. When you are working with regular expressions, especially regular expressions that you have not written, it's useful to try to read them aloud. So you should read this as, give me one or more digits, right? And so as I'm sort of going through this tutorial, try to think to yourself, like, how would I read that regular expression out loud? Okay, and then once you sort of start to do that, it makes it a lot easier to parse once you start thinking of the regular expression in sort of plain English. Okay, so I want to show sort of one concept before moving on to an additional sort of special character, and that is the difference between sort of lowercase special characters and uppercase special characters. So I am going to go ahead and show this quickly. For any lowercase special character, at least that I know of, there is a complementary uppercase character which does the opposite. So lowercase d means give me a digit. So that means that uppercase d is going to give me everything that's not a digit. Okay, so let's go ahead and run this and take a look. You can see if I remind you of what is actually in our favorites vector here, what we get out is everything except the digits, right? Once we use this uppercase d, we get everything except the digits. So this can be really helpful, right? Sometimes it's not the digits that we want, sometimes it's everything else. So keep that in mind. I'm going to show this a couple more times, but if you ever want the opposite of something, using an uppercase letter will get that for you. Okay, so I do want to show one more thing before we move on here, which is an additional stringr function that's available, which is sometimes helpful. And to show this, I'm just going to copy in this character vector favorites too, so you don't have to sit through me typing the whole thing out. The idea here is some text field existed that asked for two favorite numbers, or right, maybe it was a transcript or something, and someone was asked for two favorite numbers. Okay, so how do we get out two different numbers from our string, right? And so I want to show what happens here if you use this stir match function that we've been using. So I'll just go ahead and paste this down. We're going to use the same pattern as before. So we're going to get digits, and we're going to get one or more digit. But instead of favorites, we're doing our favorites two vector. So I'll go ahead and run this. And hopefully you were expecting this. If not, it could be pretty confusing, right? Why are we getting 42 and 10 and 33? There's two different numbers in our strings up here, right? So why are we only getting one of the numbers? The best way to explain this is to think again about the sort of greedy algorithm that's happening, right? So the parser is sort of going through our string. It's trying to match wherever it can. It gets to something that matches, great. And then our strings stop matching, right? So we get to a point where there's no longer digits. The parser stops. It returns what it found as many digits grouped together, sort of in one place. And then it just sends that back. And it's done. Okay, so if you want to get out multiple things using one pattern, there is this stir match all function, which is one easy way of doing it. It's not the only way, so we'll talk about that a bit later. But this is one way to sort of get many things using one pattern. So I'll go ahead and run this. And you can see now for each of our strings in our vector, we get back a different entry here. And then each of those entries represents the matches. So we get 42 and 12 from our first string. So all that changed here was adding this all onto our function. Okay, 10 and 15, 33 and 35. Okay, and if we actually look to see what this output is, this is just a list. And each list is going to contain what looks like a matrix. So let's go ahead and check that. We'll just index into the first entry here and call class on this just to double check. Okay, so we get a matrix back for each of our strings instead of getting one single matrix for all of our strings. Okay, that's the big difference here, is it allows multiple matches. Okay, so that's all we're going to be doing with stringr today. Is we're either going to be using stir match or stir match all, depending on how many things we want back. And like I said, tons more to explore in that package. But today we are focusing on regular expressions. Okay, so taking a step back, remember we were talking about special characters and what they do. We talked about lowercase d and uppercase d, and then we talked about this plus character. So let's keep going through some additional special characters and what they do. The next one that we're going to talk about is W. So we're going to keep using this favorites vector that I made, and we're going to keep doing stir match all. And now our pattern is, instead of D, it's going to be W. Okay, and we're going to add that plus again because we want that sort of greedy behavior. So what is this doing? Let's go ahead and run it. What's happening here? Okay, for our first string, it looks like we're getting a match for each word. Okay, why is this happening? What is W doing? Let's go ahead and take a look back here. Okay, it's matching all of the text here. So what is it not matching? What it's not matching are these spaces. And you'll see here there's a comma. If we look in our third string, it also did not match the comma. Okay, so W is giving us alphanumeric information, letters and numbers. It'll match for us. And by using all, what that did was it grouped letters and numbers that appeared together that were separated by a space or punctuation. Okay, so this is super handy if you have sort of a long string that you need to be broken up into words, for example. Okay, and like I said, this is not the only way of doing this, but oftentimes this is sort of like one handy way of doing this if you just have a bunch of alphanumeric information that you want to pull out of a string that you're dealing with. Okay, so let's take this and look at the opposite, the capital W, to see what's happening here. Run this. We can sort of confirm what we hypothesized about earlier. You can see the capital W is matching all of the spaces that are in our strings. And here it matched both a comma and a space. This is useful. Usually you aren't actually interested in commas and things, but this is one useful way of, for example, removing them all, or removing sort of extra punctuation and things like that. So that's W, lowercase and capital W, and now there's one more that I want to show, which is S. Str match all, keep with our favorites 2 character for now, and this time we'll be doing lowercase s. So let's go ahead and take a look at this. Lowercase s is going to look similar to capital W. Okay, the only difference here between lowercase s and capital W, hopefully you spotted it, is the lack of a comma. Okay, so lowercase s is going to give us all of the white space. So it will also capture, for example, tabs. And this is useful if there's going to be sort of like a bunch of white space in your text, and you just want to ignore that or handle it somehow. Okay, and one more time, let's just go ahead and compare this with the opposite, capital S. And you can see this time, the only difference here is we get the comma versus lowercase w, where we didn't get the comma. Okay, so if you're particularly interested in dealing with white space, S is useful. If you're interested in sort of dealing with all alphanumeric or non-alphanumeric information, where the big difference is punctuation, like commas and quotation marks and things like that, then W is going to be a useful tool for you. Okay, so that's just sort of a quick intro into sort of what these special characters are doing and why they're useful. But that's not really enough to like get sort of like the full power of regular expressions. It can do a lot, but to really get more power, we have to go a little bit deeper. And so let's do that now. Let's go ahead and explore sort of what else you can do with pattern matching. And to do that, we're just going to take a look at another very common special character. If anyone has any questions, feel free to throw them in the chat. Happy to take questions and sort of slow down and expand on a point. Just let me know. Or if you're watching this after the fact, go ahead and leave a question in the comments. I'll be there, sort of helping out as much as I can. Okay, so moving on now, we're going to go ahead and create an additional character vector for us to work with. So I'm going to call this fruit, and I'm just going to put in a few different types of fruit that we are interested in doing some operations with for whatever reason. Thank you for your patience while I type all this stuff out. There is a reason that I want so many, because we are going to be using this character vector for a little bit. Okay, so oftentimes, and I was sort of addressing this idea up here, right? Oftentimes we're not interested in like very specific characters. Oftentimes we don't know sort of what is going to be in our string. And so there's a very powerful concept called the wildcard. The wildcard in regular expressions is the dot character, the period character. So I'm going to go ahead and just show first what happens when we just use a single dot as our pattern. I'll go ahead and run this. And you can see we're getting out the first letter from all of our different fruit. Okay, so apple gives us A, blueberry gives us B, fig gives us F. Whatever's there is being matched, right? Because it's wildcard. So this can sort of take the place of anything. Once we have the plus symbol, right, which we already talked about, that just means give me one or more. What that's going to do is it's going to say, give me one or more of anything, of wildcard, right? Whatever's there, give me one or more of it. Now what's going to happen here? Our parser is going to look at our string, and because this can match anything, it's going to look, and everything in here is going to match, right? Because it's greedy. It's going to take up as many characters are there that fit the pattern, and because our pattern is wildcard, it's going to give us everything. So let's go ahead and run that, and we can sort of confirm that that's true. We get back actually the exact same vector that we put in, right? It matched everything. So apple stays as apple, blueberry is blueberry, apricot is apricot, etc., etc., etc. So it doesn't look sort of super useful here in this context. But let's go ahead and show an example where the wildcard sort of really shines. So to do that, we'll go ahead and match on fruit again. And let's say we were sort of interested in, maybe this is our grocery store, our shopping list, and we're shopping at a grocery store where all the fruit are hopefully categorized by the letters in the name of the fruit, right? They're in alphabetical order. And so let's say we were in the A section and we wanted to get from our grocery list all of the fruit that start with the letters A, P, okay? Because that's the section we're in. So we can start here, right? Our pattern is AP. Let's go ahead and run this just to take a look at what this looks like. Okay, right? This is the same, if you remember, as our ABC example from the very, very beginning. We just match AP, and that's it. So if it doesn't have an AP, it's NA, and if it does have an AP, the AP matches and gets returned. Okay, this is fine, but if we're at the grocery store and we need to know what actually is on our grocery list, right? We don't actually want AP returned, we want whatever this fruit is that's returned here. Okay, so hopefully you sort of see where I'm going with this. We're going to use the wildcard to match. And so how do we read this? We say, give me something that has an A and a P, and then anything for any number of characters. Okay, so let's go ahead and run that. And you can see now the AP matches, and then anything after that matches because we use the wildcard and the plus. Okay, so AP matches, but we get back apple and apricot. Cool. That is a really important idea, right? Because oftentimes in strings that we're actually dealing with, there's going to be sort of a bunch of stuff that we don't want to make any claims about, right? So maybe there's just like a bunch of stuff at the end of our string. We don't really care what it is. We want to match it because we want to include it in the output, but we don't know what it's going to be, and we don't really care about it. So you'll see this sort of pattern in regular expressions all the time. Okay, next big idea. Let's sort of remember what we learned about the wildcard, and now add in a little bit more complexity with conditions. So now we're getting into the stuff that make regular expressions like really, really cool. Let's say the A and the B section are pretty close together, so let's just get all of the A and B fruit that we're interested in. How do we get all of the fruit that start with A and all of the fruit that start with B at the same time? We do that with square brackets. Okay, and in the square brackets, we give all of the options that would match sort of in this location. So something with an A in it matches, and something with a B in it matches. And like we saw before, right, we don't want to just run this. If we just run this, we're just going to get back A's and B's, right? We want sort of the full fruit. So we add the wildcard and the plus, and now we get back the full name of our fruit. Okay, so the square brackets are making everything in here conditional. What would happen if there were no square brackets? We can go ahead and run this, and you can see it's all NAs. Why is that? Well, let's look at our fruit. None of our fruit start with an A and a B. Okay, so what this is saying, how you would read this is, give me something that has an A and a B, and then one or more wildcard characters. Once we add the square brackets back in, we read it as, give me something that has an A or a B, and then one or more wildcard characters. Okay, so I'll go ahead and run this again to compare it. This now matches our apples and our blueberries and everything else. Okay, so conditional information is the sort of thing that when you need that, you probably need to turn to regular expressions. For a lot of the stuff we've talked about so far, you could do it without regular expressions. We're just sort of providing building blocks here, but conditionals, especially if you have like more than two, that's the sort of thing where I'm like immediately turning to regular expressions. I'm never going to try to use like a built-in method to handle that sort of stuff. Especially if there's more than two conditions, because it ends up being messier than the regular expression itself. Okay, so conditioning is really cool and useful. We showed how the wildcard is really useful with the plus. I do want to show one more special character now that we've sort of seen what the wildcard and the plus can do together. And that wildcard is the asterisks. So, oops. So to show how this differs, I think the easiest thing to do is just define a single empty string here. So this is an empty string with nothing in it. And what I'm going to do is match the sort of wild card with the plus that we've been doing so far to see what the outputs look like. So take a second and just sort of think like, what output would you expect here? So we know what the wild card does. That'll match anything. And think about what the plus does. Think about sort of how I've been vocalizing the plus symbol. Okay, so I'll go ahead and run it. We get back NA. Okay, this might be a little bit confusing, right? Because remember before when we used this pattern, we got back sort of exactly what we put in and nothing changed. That's because none of these strings were empty, right? There was something to match. Remember that plus symbol means one or more. So one or more wildcard. But because it's totally empty, there's no match, and we get back NA. So how do we deal with this? Like, what if we sort of want empty strings to be matched for some reason? Or what if, in maybe like a more realistic example, what if it's possible that there's a bunch of stuff at the end of our strings, but it's also possible that there's nothing there? And even if there is nothing there, we still want to match on all of the other stuff that's in our pattern. This is where the asterisk comes in. The asterisk is just 0 or more. Okay, so I'll go ahead and run this. We can take a look. You can see this matches an empty string. Okay, so when used with the wildcard, the plus says there has to be at least one character in the string or I'm not matching. Here, it's saying it can be empty or it could have a bunch of different characters. It's all the same to me, right? So that's the difference between the plus and the asterisk. Plus should be read as one or more. Asterisk should be read as any number, 0 or more. Okay, cool. So I want to go through sort of like a couple examples of maybe slightly more realistic situations here. In particular, we're going to sort of play around with this wildcard plus and wildcard asterisks. But we're also just going to sort of do some basic operations that I think will sort of give a better sense of what we can do with regular expressions. That are the sorts of things that are maybe a little bit harder to do in other sort of styles. So I'm defining a character vector here. I don't have a good story for this one. It's a list of strings that all have the substring grape. This one is grape seed oil. There we go. Okay, so these are our grape things. Okay, and now let's say we're sort of interested in this particular substring, right? We're interested in the substring grape. And so let's just go ahead and match using our wildcard pattern that we were using before with the plus sign and see what happens. This is sort of like an example of where the difference between a plus sign and an asterisk really matters. So, oops, sorry. We want to match grape, right? We don't want to accept anything. We want only the strings that actually start with grape. And then, you know, for all of these, there's stuff after. So we just say, you know, if there's stuff after, that's cool. So what's happening here now? All of these match just fine, but because our first entry has nothing after it, we get NA back. And probably that's not really the behavior we were expecting in this case. And so maybe it would have been better to use an asterisk. So let's see what happens. I'll just go ahead and copy paste this to save a little bit of time. Throw an asterisk here instead. And we can see we match grape. Okay. It's okay that there's nothing after. We still want this entry to be returned. And so this is an instance where we would want to use the asterisk over the plus. Okay. Next, we are going to go ahead and do a sort of slightly different example here. We are going to define some cat things. And again, no real story for this one, except that this is just useful for showing off our next concept, which is going to be using special characters to define the beginning and end of strings. So here we're going to have a bunch of different strings that all start with cat, except the last one here, which is house cat. Okay, so what are we doing here? I want to show what happens, for example, if we wanted to get all of the entries in our character vector that start with cat, right? So that's our goal. So we'll go ahead and use stir match, and we'll sort of follow the same pattern we've been using, where we stick in sort of cat, and then there's some stuff after, right? So let's run this and see what happens. Okay, caterpillar, caterpillar, cattle, makes sense. What's this? Cat. Why did cat come up here? Why is that not house cat? Why is it not NA? We wanted things that only started with cat. This is kind of confusing. Now we could fix this, right, by doing that, but that's not really the concept that I want to show here. Maybe we really do sort of want to accept cat as an option, right? So let's say we had cat here, and maybe that's valid input that we want to accept. So this is right. It's matching cat now, but house cat is not something we want to match, right? That doesn't start with cat. That's not what we want. So how do we actually say that, you know, we want cat to be at the start, at the beginning. To do that, we use the caret symbol. So I'll go ahead and show that. Go ahead and match again. We'll use the same pattern, except this time we are just going to use a caret symbol at the start of our pattern. Okay, this indicates this is the start of our string. And immediately after the start of our string are the letters CAT. And then there is a wildcard. Okay, so how would we read this? At the start of our string, there are the letters CAT, and then there are 0 or more wildcard characters. So let's go ahead and run that. We can see, okay, now we get caterpillar, catapult, cattle, and our cat that I added here. Those all occur at the beginning of our string. Great. House cat, because the cat is not at the start, we get NA. So that's exactly what we wanted. Perfect. Okay, so let's say we wanted to do the opposite. Right, what if we're going to keep with our cat things vector here, but instead of getting all of the entries that have cat at the beginning, maybe we only want the entries that have cat at the end. How do we do that? Well, sort of following off our pattern here, we could say there should be some stuff, and then there should be cat. Okay, so let's run that and see what happens. 0 or more wildcard characters, and then the string cat. Okay, maybe this will do what we want. Let's take a look. Okay, cat, that looks good. House cat looks good. Okay, these are both entries that, as we want, have cat at the end of the string. But these are all also cat. What's going on there? Well, this is 0 or more characters, 0 or more wildcard characters. So that's sort of this empty space before caterpillar. And then cat matches. Cool. And then that's it. It returns. So that's why for all of these entries, we're just getting back cat. Okay, so to fix this, what we're going to do is use the $ symbol. The $ symbol indicates the end of a string. So what changed? Here we would read this as 0 or more wildcard characters followed by cat. Now we would read it as 0 or more wildcard characters followed by cat and then the end of the string. So let's run this. And now, okay, caterpillar and catapult and cattle, none of those match, but cat matches, right? The end of the string occurs right after the letter CAT, and there's 0 or more wildcard characters before that, so great, that matches. And then house cat also matches, because cat occurs at the end, and then immediately after the letter CAT is the end of the string. Okay. So those are pretty much the special characters that I wanted to talk about. Any questions? Oops. Any questions before I sort of move on to the next big topic that I want to discuss, which is capture groups. Like I said, if you're not watching this live, leave a question in the comments, and happy to sort of answer those as they come in. Okay, so let's talk about capture groups. And to do this, I'm going to create a new character vector, captures. And these are all things that we want to capture, like a Bulbasaur or a flag. You can capture the flag, or maybe a photo. Okay, these are all things that we would like to capture. I'm going to go ahead and type in a somewhat confusing pattern here, but it's using tools that we already know. Oh, sorry, this should all be one string, because we are doing capture groups. There we go. There we go. Okay, so sorry, we have only one string here, right? Bulbasaur, flag, and photo. And our task is to sort of pull out each of these things. Remember I showed like one way that you might do this earlier with stir match all. But the method that I'm going to show now is like a little bit more flexible. And so it's a really important one to learn, even though this particular problem could be solved in a different way. Okay, so like I said, I'm going to go ahead and create a somewhat confusing pattern here. And just bear with me as I type all of this out. While I'm doing this, try to remember what W is used for, and see if you can anticipate what the different parts of this pattern are going to match. Okay, and then one more. Okay, so I know that looks pretty confusing, but remember we already talked about \W and what this does. This is going to give us alphanumeric characters. This is going to give us a bunch of stuff that is not alphanumeric characters. And remember, the asterisk says 0 or more. Okay, so you can read this pattern as give me all of the alphanumeric characters that you can find before the first non-alphanumeric character. Once you get there, give me all the non-alphanumeric characters you can find, and then give me all of the alphanumeric characters you can find after that, and then give me all the non-alphanumeric characters you can find, and then give me the final alphanumeric characters all the way to the end of the string. Okay, and notice, right, this is all one string now. So if we want to sort of pull out these individual things, we need something a little bit more complicated than when we were sort of going over the strings individually as if they had sort of already been separated out for us. Okay, so let's go ahead and run this and see what we get out. For the first time since the very beginning, when we were looking at the phone numbers, we're getting sort of multiple entries back. We get the match to the overall string, so that's in our first column of our matrix here. But we also get out Bulbasaur and flag and photo. Okay, so it's done sort of some separation for us. Like I said, this is like not the most efficient way to do this, but I'm trying to show a concept here. The concept is these parentheses, which are new. Okay, the parentheses represent what are called capture groups. Okay, that's why these are all things that you capture. Okay, when you use a parenthesis, you're saying this part of the pattern is sort of particularly important, and I want you to give that to me. Okay, and the way sort of stir match handles capture groups is to make them sort of separate columns in the output. Okay, so this is the first capture group, this is the second capture group, and this is the third capture group. Okay, these are all of the alphanumeric characters at the beginning, and then we have some non-alphanumeric characters, those get dropped. And then we have some more alphanumeric characters here in our second capture group, right, because that's where the parentheses are. And then we have some more non-alphanumeric characters, and then our final capture group picks up the rest of the alphanumeric characters. So hopefully that makes sense. Maybe it's not super clear why capture groups are useful yet, but they will be important when we talk about phone numbers again. And I wanted to explain it now because we are going to start getting more output sort of in this format because we're going to use the parentheses also for other things. And so I just sort of wanted to explain why the output looks like this and what's actually happening here with these parentheses. But this idea of capture groups will be coming back at the very end. So, okay, with that out of the way, I just sort of want to go back to our fruit vector here, our character vector of our different fruit. And now I want to solve a slightly different problem than what we solved before. So before we did this, where we passed in our fruit, and we had a pattern where we had a conditional, which was A or B, followed by a wildcard. Okay, and remember we managed to get our apples and our blueberries and our apricots and our Asian pear and our banana, right? Everything that started with A or B. Let's say, though, that we are sort of doing something more complicated and we want more than just a single letter, right? So what if we want anything that starts with AP or anything that starts with BAN? Okay. You might try to do something like this, like AP BAN. So let's go ahead and run this and see what happens. Okay. Our intention, right, is to get apple and apricot and banana back. But you can see this is still giving us blueberry and Asian pear, which we don't want. Okay. You can't use a conditional with multiple letters like this, like you might sort of be inclined to want to do. Instead, if this is the sort of thing that you need, you should use parentheses, okay, instead of those square brackets. Those square brackets are a single character or like special characters like the digit special character. Conditionals, okay? You can't do this sort of like more complicated stuff here. When we use parentheses, though, this sort of conditional is valid. So let's go ahead and run it. You can see we get apple, apricot, and banana back. So these are the things that match. And because we're using parentheses in our sort of second column here, we get the match, right? Which is either going to be AP or BAN. Okay, so this is probably not in this case what we're particularly interested in. We're probably more interested in this first column. But this is why I wanted to explain capture groups sort of in advance so that this actually made sense. Okay, cool. So that is more complicated conditionals with multiple letters. Next, I want to show repetitions. Getting close to the end here. This is sort of the final concept that you need to understand our phone number regular expression. So if you're still with me, thanks for sticking it through this far. Almost sort of at the point where we can look back at the very beginning and understand what that complicated pattern was doing. So to talk about repetitions, I just need some words that have repeating letters in them. So I have banana with this NANA repeated, and papaya with the PAPA, and can repeats. Okay, so that's what we're going to be working with here to talk about repetitions. Go ahead and use stir match again. Put in repetitions. And this time for our pattern, we're going to introduce sort of like one additional grouping character, and that is the curly brace. So here I'm going to put in the syllables that we want to capture, right? That we want to be present. But we don't want to accept a word that just has any NA. Okay, we're looking for repetitions, right? We want NA to be repeated. Okay, we want it to be repeated twice in order to match this banana string. Okay, so that is what the curly braces do for us. They say, give me everything that comes before the curly braces this number of times. Okay, so how would we read this? We would say match anything that has an NA, a PA, or a CAN repeated twice. Okay, so let's run that. And you can see it matches the NA, the PA, and the CAN. Okay, and because we're using parentheses here, it's doing that capture group behavior. You can turn this off, but it's kind of outside the scope of what we're talking about today. So we're just going to leave that be for now, because it's not really too much of an inconvenience for us. Okay, so that's repetitions with the curly braces. You don't necessarily need repetitions when you're writing regular expressions, but they can really reduce clutter and make a regular expression a lot easier to read. So with that, let's go ahead and return all the way back at the beginning to our pattern, and I guess I'll just go ahead and print it out down here again so that we can take a look at it. So remember, this is the pattern that we use to pull out phone number information. Let's go ahead and sort of read through this just to sort of figure out, now that we know a little bit more about regular expressions, what's actually happening here. And just as a reminder of what this actually did, we used this on our phone numbers vector, and we got out from these sort of messy, ugly formatted strings the area code and the rest of the phone number separated out for us. Right, and our final phone number didn't match because that was just a string that said, I do not have a phone number. Okay, so let's go ahead and read this and figure out what this actually does. If you want to pause the video and sort of work this out for yourself, go for it. Otherwise, I'm going to go ahead and suggest sort of like how I would read through this. Okay, so we talked about the wildcard. We talked about the asterisks. Taken together, this means 0 or more characters that could be anything. Okay, the wildcard matches anything. So some stuff at the beginning is what this says. Followed by a digit, and specifically any digit that repeats 3 times. And then 0 or more wildcard characters. This pattern again. 0 or more wildcard characters. And this pattern again, except this time it's 4 digits. Okay, and note that each of these patterns are wrapped in parentheses, which means they are being captured. So we don't care about all this junk at the beginning. What we care about is 3 digits that appear in a row, followed by some more stuff we don't care about that may or may not be there, followed by 3 more digits that we do care about, so we're going to capture those, some more stuff that may or may not be there that we don't care about, and then 4 digits that we do care about. Okay, this isn't a perfect phone number regular expression. If you are actually writing code that needs to parse phone numbers, don't use this because, for example, if there's like a +1 at the beginning, this won't work. But for today's purposes, I think hopefully you found this useful, sort of starting with this complicated pattern, and now at the end, hopefully being able to read this and understand what's going on. So yeah, that's pretty much it for today. I hope you enjoyed this week's video. If you did, if you're enjoying the videos or you have questions, go ahead and just leave a comment. Let me know so that I know you're out there and you're watching, and you know, this is useful for you so that I keep doing it. Okay, that's pretty much it for today. Like I said, go ahead and if you want more practice, check out this regex1 site, which is really great for sort of doing some interactive tutorials to really get some hands-on experience with regular expressions. And let me know if you use regular expressions in your work and they end up being useful. I'd love to hear about it. Cool. Okay, so that's all for this week. Hopefully you enjoyed, and I hope to see you next week.